Good afternoon all. My name is Durga Devi. I am working as an assistant professor in Department of CSE in B.V. Raju Institute of Technology, Narsapur. Today I am going to explain the concept of greedy method in the subject Design and Analysis of Algorithms. Today I am going to discuss a greedy method. This greedy method is one of the problem solving technique in design and analysis of algorithms. Basically, we have 5 different techniques in design and analysis of algorithms. Those are divide and conquer method, greedy method, backtracking method, dynamic programming method, and last one, branch and bound method. Today I selected greedy method to explain you. The greedy method is one of the problem solving technique. This technique is used to solve optimization problems. Okay, in the greedy method, here I covered the general method of greedy method and then applications, minimum cost spanning trees, knapsack problem, job sequencing with deadlines problem, and single source shortest path problem. First of all, I started first one, minimum cost spanning trees application. The greedy method is an approach to solve optimization problems. Here we follow some specific technical terms like optimization solution, feasible solution, and objective function. This greedy method is one of the major technique to find optimal solution among all feasible solutions. What is feasible solution? Feasible solution means we have a problem here. For example, every problem having number of solutions. For example, here I want to travel from Hyderabad to Vijayawada. Suppose Hyderabad to Vijayawada I want to travel. So for this, we are having number of ways. So how we travel from Hyderabad to Vijayawada? So we have by walk, and second possibility by cycle or by using car, by using bus, and by using flight. So these are 5 possible solutions to travel from Hyderabad to Vijayawada. So these are total possible solutions. So these are solutions here. Among these solutions, I am applying one constraint. One constraint I am applying here. What is that constraint? I want to reach Vijayawada by 8 hours. So 8 hours I am applying here a constraint. So now what are the possible solutions we have? Among all those possible solutions, I filtered some possible solutions with applying some constraint. What is that constraint? Means 8 hours. So here now what are the possibilities? One is car, another possibility bus, and another possibility by flight. So these are possible solutions when I am applying that constraint within 8 hours. So these 3 possible solutions are called as feasible solution. That is the meaning here. For solving a particular problem, there exist n inputs and we need to obtain a subset that satisfies some constraints. So these 3 possible solutions here called as are feasible solutions. So these are feasible solutions. Now, what is optimal solution? Optimal solution means, so which particular feasible solution gives optimal value. Optimal value means minimum value or the maximum value depends upon the requirement of the user. So here optimal solution means gives a minimum value or the maximum value. Before that, what is objective function? Objective function means like minimum value or the maximum value. So among these feasible solutions, I am applying another optimal function on these feasible solution. What is that means? Here I am applying optimal value like minimum. So I am applying here minimum is the optimal value. Now what are the possible values, possible solutions? That is, the only solution is bus. Within a minimum cost from Hyderabad to Vijayawada I traveled. That is the bus. Bus is here optimal solution. So this optimal solution is obtained using greedy method here. Using greedy method, I want to find the optimal solution among all possible feasible solutions. So this is the introduction about the greedy method. Here we are applying feasible solutions and optimal solutions. Now moving to the applications. The first application is minimum cost spanning trees. Before going to the main concept of minimum cost spanning trees, I want to explain what is spanning tree. What is spanning tree means? Simply, a spanning tree is a subgraph of a graph which is covered all the vertices with the minimum edges. That is a definition of spanning tree. For example, here I am taking 4 number of vertices with 6 edges. I am taking graph. Now convert or generate a number of spanning trees for the given graph. Here we have 4 vertices and 6 edges. 4 vertices and 6 edges. Now spanning trees, generate a spanning trees for the given graph. So this is a one spanning tree and this is another spanning tree and this is another spanning tree. So for one graph, we have to generate more number of spanning trees. Depends upon the taken vertices and edges. And we have another possibilities also of spanning trees. So like this. This is also one spanning tree. This is also another spanning tree. And this is also another spanning tree. So we have number of possibilities to generate a spanning trees. So this is about the spanning tree. The spanning tree contains, suppose n number of vertices, a graph contains n number of vertices, then that spanning tree contains n minus 1 number of edges. This is the given graph and this is a spanning tree edges. Graph contains n number of vertices, then spanning tree contains n minus 1 number of edges. This is about the spanning tree. Now we are moving to the main application, minimum cost spanning trees. So what is minimum cost spanning trees means? For this minimum cost spanning tree, we have to take undirected graph and weighted graph. So weighted graph with undirected edges. Okay, now what is minimum cost spanning tree? So for this graph, we have to generate number of spanning trees like this. Now, what is the cost of a spanning tree? We have to add all these edges, then we get a spanning tree cost. 3 plus 2 plus 1, that is 6. So 6 is the spanning tree cost. Like this. We have to generate number of spanning trees here. So for example, here we have to take this one. Then what is the cost? 2. 4 is the edge cost. This is the 1. So 4 plus 2 plus 1. Totally we have 7. Coming to here. This is 2. This is 3. And this is 1. Again we have the cost is 6. Coming to here. This is 4. This is 5. This is 1. Now what is the cost of this spanning tree? This is 10. So these values are the spanning tree costs. Like this, we have number of spanning trees and number of costs. Among all these possibilities of spanning trees, you have to filter a minimum cost. Suppose 6. So 6 cost is the minimum cost. Then this is considered as the minimum cost spanning tree. So for this minimum cost spanning trees or for this spanning trees, suppose we have n number of vertices of a complete graph is there with n number of vertices, then how many possibilities we have to generate a spanning trees means n power n minus 2. So this is the spanning trees number. N number of vertices of complete graph. We have n number of vertices of complete graph. Then we are having the possibilities like n power n minus 2 is the formula for calculation of spanning trees, possibilities of spanning trees. For example, here I am taking 3 number of vertices of complete graph. Complete graph means every vertex is connected to remaining all vertices of graph. Suppose here A, B, C. So this is 3 vertices complete graph, 3K graph. Now, how many number of spanning trees are possible means by using the formula n power n minus 2 means 3 power 1 is equals to 3. That means 3 spanning trees are possible. So, what are those spanning trees? 3. So, these are the 3 possibilities of spanning trees. Suppose I am taking 4 vertices complete graph, 4K graph, then we have 4 power 4 minus 2 number of spanning trees. Like total 16 possibilities are there to generate a spanning trees. Now, for example, I am taking 5 vertex graph. Then, how many possibilities? 6 number of vertices. Then, how many number of spanning trees are there? Here we have only 3 vertices or 4 vertices. Then you have to generate all 16 possibilities and filter a minimum cost spanning tree. Suppose 5 number of vertices are there, 6 number of vertices are there. Then, how many possibilities are there? How we filter a minimum spanning tree among all possibilities? So, it is very complex. So, that's why to overcome this problem, we use 2 algorithms to find a spanning trees, minimum spanning trees, MSTs. So, what are those 2 algorithms here? Kruskals algorithm and Prim's algorithm. So, Kruskals algorithm and Prim's algorithm, using these 2, you have to find a minimum spanning tree very simply. So, what is the procedure we are following in Kruskals and what is the procedure we are following in Prim's? Now, we have to discuss. These 2 algorithms procedure is very somewhat different to one by one, but the result is same. The resultant spanning tree is same, the resultant cost of spanning tree is same, but procedure is different. So, what is the procedure of Kruskals and what is the Prim's procedure? Now, we have to discuss. The first one is Kruskals algorithm. Here, in Kruskals algorithm, we follow 3 steps to generate a minimum spanning tree. What are those 3 steps and what is the procedure? Now, we have to discuss. Okay, step 1. What is the step 1 we follows in Kruskals algorithm? Step 1 is sort all the edges from low weight to high weight. How many number of edges are there, how many number of vertices are there, we are not bothering about that graph. For the given graph, what is the step 1 we are following means, here we have to sort all the edges weights from low weight to high weight. That is the step 1. What is the step 2? After arranging all the edges in sorting order, we have to take one by one edge and connect all the edges in sequence. Suppose when we connect all the edges, if the graph contains a cycle, it forms a cycle means you have to reject that particular edge. Then we are moving to the next minimum weight edge. This is the procedure we follows in step 2. And coming to the step 3. The same step 2 will be repeated until we reach all the vertices. We have to follow the same step 2. Finally, we get the MST, minimum spanning tree. So, these are the 3 steps we follows when we follows a Kruskals algorithm to generate a spanning tree. So, these 3 steps will be explained with one example here. So, this is the taken example here. This example contains totally 7 number of vertices and 9 number of edges. So 7 number of vertices and 9 number of edges we have here in example. So for this graph, construct a minimum spanning tree for the given graph using Kruskal's algorithm. This is the question. So what is the solution for this question means here? The first step is what? We have to arrange all the edges weights from low weight to high weight. So low weight to high weight means here I arranged already here the first edge with the 10 cost weight, 10 weight. So that is 1 to 6 edge. Then second one 3 to 4, 3 to 4 with cost 12. So like this already arranged here, minimum weight to higher weight. Step 1 completed. Now we are moving to the step 2. What is the step 2 means? We have to take one by one edge from sorted order and connect those edges and forms a tree. That is the step 2. So what is the step 2 here? So minimum weight edge is first one is 10 with the 1 6 edge. So connect 1 6. Next step is what? Next minimum weight here. Next minimum weight is 12. So take that 12. Yes, the 12 edge 3 4 is also connected. Next minimum edge weight is 14 is connected, and next 16 that is also connected. Now next minimum weight edge is 22 is connected. Next 25 that is also connected. So whenever we following the procedure, if the graph contains a cycle, forms a cycle means you have to reject that edge like this here. Here I draw the resultant spanning tree here. 1 6, yes, 1 6 with weight 10. Now the second edge weight is 3 and 4. So 3 and 4, this is 3, 3, 4 with weight 12, and 2 7, 2 7 with 14, yes, this is 2, this is 7 with 14. Now fourth edge is 2 3 with 16. 2 3 with 16 means connected 2 and 3 with 16, yes. Next 4 and 7 with 18. 4 and 7 with 18, yes. But we don't consider this edge. Why means when we connect these two vertices, it forms a cycle here. It forms a cycle. That's why we reject this edge. We reject this edge. So reject this edge. Now move to the next weighted edge, that is 4 and 5 with 22. 4 and 5 with 22, yes, connected. Now next 5 and 7 with 24. 5 and 7 is 24 means it also forms a cycle. That's why we reject this edge also. So rejected. Now finally 5 and 6 with 25. Yes, 5 and 6 connected with 25. Yes, and last one 1 2 with 28. 1 2 connected means it again forms a cycle. So reject this particular edge also. Rejected. So finally all vertices of a given graph, 7 vertices are visited here. Yes. Then what are the number of edges? 6 edges. 6 edges and 7 vertices. Already I told you the beginning of a spanning tree is, a spanning tree contains how many number of edges means depends upon the taken graph vertices. N vertices are there, then number of edges are n minus 1. Here 7 vertices are there in the given graph, then we forms here spanning tree forms 6 number of edges, n minus 1 edges with n number of vertices. So this is a required spanning tree. Minimum spanning tree. Now, what is the minimum spanning tree cost? So, how we calculate a minimum spanning tree cost means here we have to add all the edges weights. 10 plus 25 plus 22 plus 12 plus 16 plus 14. So, totally we have 99 units. So, this 99 units represents a minimum spanning tree cost. So, this is required spanning tree using here Kruskal's algorithm. So, this is about the Kruskal's algorithm. Now, we are moving to another algorithm, that is Prim's algorithm. What is the procedure we are following in Prim's algorithm, and what about the example, and what about the minimum cost, we have to discuss now. So, what is spanning tree means? A spanning tree is the subgraph of a graph which covered all the vertices with minimum number of edges. Suppose n number of vertices are there, then the spanning tree contains n minus 1 number of edges. So, like this, step by step procedure. First we have to take a minimum cost edge, after that minimum cost edge, after that, until we follows the same procedure to reach all the vertices and n minus 1 number of edges. So, finally, this is the resultant spanning tree. And what is the cost? 10, 25, 22, 12, 16 and 14. All weights is added here. The total is 99 units is the minimum spanning tree cost is equals to 99 units. So, this is about the Kruskal's algorithm spanning tree. Now, we are moving to Prim's algorithm. So, this is algorithm Kruskal's. Kruskal's algorithm, what are the steps we are following here, whatever the procedure we are following here, that will be mentioned in this algorithm. So, first one is algorithm header. Algorithm header syntax is algorithm keyword and algorithm name, and what are the parameters you are using the algorithm, that will be mentioned here. Here algorithm Kruskal is the name of the algorithm, and E is the number of edges, cost of the edge, and n number of vertices, and T is the traveling cost. So, these are the comment lines. E is what, U comma V is what, whatever you have to mention in the parameters list, that will be taken in the comment lines here. After that, what is the procedure we are following here? By using the heap sort. By using heap sort, you have to arrange all the edges weights in the order, sorting order. After that, you have to perform all these steps. This is about the Kruskal's algorithm. Now, coming to the Prim's algorithm. So, Prim's algorithm also here follows 3 different steps to find out a minimum spanning tree. So, what is the step 1? In Kruskal's algorithm, we arrange all the edge weights from low to high. So, here we follows in step 1, randomly we choose a vertex. How we choose a random vertex? Basically, which one having the least weight among all the edges, that will be selected randomly here. That is the first step. What is the step 2? What is the step 2? Find all the edges that connect the tree to new vertices and find the least weight. Among all these selected vertices, new vertices, you have to select the least weight edge and connect into the existing tree. Now, if including that edges creates a cycle like Kruskal's algorithm, if cycle forms, then you have to reject that edge and look for the next least weight edge. The same. And third one, you have to repeat the step 2 until you reach all the vertices. Then finally, we got a minimum spanning tree. So now, how we apply these three steps? These three steps on example. How we apply these three steps in example here. The same example here with 7 number of vertices and 9 number of edges. Construct a minimum spanning tree using Prim's algorithm. That's the question. Now moving to the solution, how we find a minimum spanning tree. So what is the step 1? Step 1, we have to choose a minimum weighted edge. Randomly we have to choose one edge. Which one that edge means here? Which one having the minimum cost? So here among all these 9 edges, which one is the minimum cost? 1 and 6 is the minimum cost. So here I am taking 1 and 6 with minimum cost. Step 1 completed. Randomly choose any vertex, which one having the minimum cost. Now we are moving to the step 2. What is the step 2? Step 2 means we have to find all the edges which are connected to these vertices. Here we have only 1 and 6 vertices. So you have to find which edges are connected to 1, which edges are connected to 6, which edges are connected to 1, 1 to 2 and 1 to 6, which edges are connected to 6, 6 to 5 and 6 to 1. Already 6 and 1 are connected. So you have to move 1 to 2 and 6 to 5. So 1 to 2 and 6 to 5. 1 to 2 weight is 28 and 6 to 5 is 25. So you have to select these two actually. Now among all these two, which one having the minimum cost, that will be selected to connect the spanning tree, required spanning tree. So that's why you have to select 6,5 edge, 6,5 edge with the minimum cost 25. Now again we repeat the same procedure. Again we have the vertices 1, the vertex 6 and the vertex 5. So again 1 to 2 we have edge with the cost 28. Again 6 to 1 already visited, 6 to 5 already connected. Now 5 to 7 is there with 24 cost, 5 to 4 is there with 22 cost. Now among all these three, which one is having the minimum cost, that will be selected to form a MST. So 22 is the minimum cost with the edge 5 and 4. So 5 and 4 with the cost 22. Now again you apply the same procedure. Again we have vertex 1, vertex 6, vertex 5 and vertex 4. Again 1 to 2 we have 28. Again 6 to 1 already connected, 6 to 5 already connected, then 5 to 7, yes 5 to 7 also there with cost 24. Again 4, coming to the 4 to 7 also there with 18. Again 4 to 3 also there with 12. So among these 4, which one having the minimum cost? So 12 is the minimum cost with 4 to 3 edge. So note down that edge. Yes. Now again here 1 to 2 with 28. Again 6 already completed. 5 to 7 with 24. 5 to 4 also completed. Then 4 to 7 with 18. Next 3 to 2 with 16. Again among all these 4, you have to select the minimum, that is 16. So connect 3 to 2 with 16. Now again we follow the same. Yes. Now again 1 to 2 with 28. 6 completed. 5 to 7 with 24. Again 4 to 7 with 18. Okay. Then 2 to 1 already noted here 28. 2 to 7, yes, 2 to 7, 14 is there. Now among all these, you have to select minimum wage, that is 14 with 2 and 7. So 2 and 7, you have to write that edge with 14. Then we have to continue the procedure? No need. Why means here all vertex 7 total vertices are visited. Yes, all vertices are completed. Then you have to stop the procedure. Now again calculate a MST cost. So 10 plus 25 plus 22 plus 12 plus 16 plus 14. Again we have 99 units. So the cost of a spanning tree is same in Kruskal's algorithm and Prim's. But whatever the procedure we are following is different. Here you have to observe that the spanning tree also same, which is obtained in Kruskal's. Yes, the same spanning tree, the same cost. But what is the procedure we are following means that is only the difference. Okay, in Prim's algorithm, we follows the procedure. What is the step 1? First of all, you have to select a random weighted edge. So, how we choose that random edge means which edge having the minimum weight among the given graph, you have to select that one. Yes, the step 1 completed. Now, what is step 2 means? You have to select all the edges which are connected to the already placed edge vertices. Among all those, you have to select the next one and again connect it with that particular edge. If suppose the cycle is forms means, then you have to reject that edge and go for the next minimum weight edge. Finally, all the vertices are visited. Then finally we get the MST with the minimum cost. So this is the procedure of Prim's algorithm. Now you have to check the result of this Prim's algorithm. Resultant MST. Here, this is the first step. We have to select a random vertex and after that among the all the edges which are connected to 1 and 6, we have to select a minimum weight and after that next, and finally we reach a required minimum spanning tree and the cost is 99 units. Yes, this is the Prim's algorithm. Kruskal's algorithm and Prim's algorithm, these two are used for the finding a minimum spanning tree among all possibilities of spanning trees. Now, algorithm of Prim's. In Prim's algorithm, again algorithm header and what are the parameters we are using and after that what are the comment lines of parameters. What are the parameters, why we are using, that will be mentioned in the comment lines and after that we have to choose one by one edge. So this is the algorithm we follows in Prim's. So these two are minimum spanning tree algorithms. So by this the one of the application of greedy method is completed. Yes, thank you all.
Like, share and subscribe. Hit the bell icon for more updates.